Okay, this is going to be much quicker. This next problem is problem 3. You need your chart to do this. Quick here. All I'm doing here is asking, which of the following reagents can oxidize water to oxygen gas under standard state conditions? Standard state conditions just means you're using this chart. This chart's standard state conditions, 25 degrees Celsius, 1 molar solutions. So it says here, which of the following, and there was a whole bunch of choices. You got some hydrogen ion, chlorine gas, copper 2 ion, lead, manganese, permanganate ion. And so which of those could oxidize water to O2? Now, water to O2 has got to be on here. I was talking about water to O2. Let's find water to O2. Here's about 1/4 of the way down, 1/3 of the way down. O2 to going to water. I have O2 making water. Is that what it's talking about? Yes. But that said water to O2. Exactly. Think about it. Does H2O, and that here is saying H2O. It says H2O to O2. Does it want to do that? You've done enough chemistry this semester. You know that water does not like to break down. All those K values, and it doesn't want to do that, right? The only way to get that to happen, to get water to go in the opposite direction, would be, well, this is showing O2 and hydrogen making water, which is what we would expect. So this is showing the reduction potential for that to happen. So this means this wants to go in this direction. We want to take oxygen, we want to have 4 hydrogens, add four electrons to it, and get some water produced. It's pretty high up on the chart. That's a reduction equation, and it wants to happen. Higher up, the more you want the equations, the way they're written, to go the direction they're going, and that is to get reduction. In order for this to not do that, you're going to have something which is a stronger reducing agent involved with it. In other words, if you're going to make this turn around and go from H2O, giving away 4 electrons, reversing the reaction, giving away 4 electrons would be an oxidation. The only way to make it oxidize, make that water oxidize, is to combine it with something which is stronger, a stronger reducer than that water equation. And the only way to do that is you're going to have to find something on the chart that's above the water reaction. If you're above the water reaction, you are a stronger reducing agent. You will do reduction, and anything below it, remember, becomes oxidized. So we have to find any of these. Okay, so we would go down the list. Look. Oh, check it. Now, do any of these on here, the hydrogen, the chlorine gas, the copper, the lead, the permanganate, the only 2 things on this choice list that are higher up than the water reaction are the chlorine gas and the permanganate ion. So I would only see, so there's my water, and the permanganate's higher, and the chlorine gas is higher. Those are a little higher, and what that means is those want to be reduced more than the reaction involving the oxygen, hydrogen making water. So the only way to get that reaction, oxygen, hydrogen making water, to reverse and become oxidized, that means giving away your electrons, is to have a stronger reducer. Those are the only 2 greater. Everything else is below. So everything else below, the lower you are, the more you want to be oxidized. The higher you are, the more you want to be reduced. So those higher 2, the permanganate and the chlorine, want to be reduced more than that water reaction. All right, so those are the only 2 that would force that reaction to switch and have the water become the oxygen, the hydrogen, and give away those electrons and become oxidized. All right, okay. You might have to listen to that one a couple of times in order to try to figure that out. I'm not saying this is I'm not promising no rose garden here, people. But it was a shorter video. I did promise you that. Boom.